Good morning. Today we are doing the lecture for real numbers. This should be the fourth day of class, lecture 1.3. All right, here is a chart to help you differentiate between the two, all of the different types of real numbers. So you have natural numbers, oftentimes referred to as counting numbers. That's why it doesn't start with 0. We don't naturally start with 0 when we're going to count things. If I have 5 sheep in front of me, I don't go 0, 1, 2, 3. No, we count them. 1, 2, 3, 4, 5. So, natural numbers. Whole numbers are natural numbers with the 0. Now you can do the 0. Now, integers are whole numbers with all of the negatives. Okay, so now we can do the -1, -2, -3, -4, etc. Rational numbers can be expressed as a fraction. So now we have most of the numbers between each whole number. So we can do 2 1/2 and 2 3/4 and 5 4/3 and 4/3 is greater than what? 5 2/3. There you go. All right, so those are rational numbers. They can be expressed as a fraction. Now notice that things like a -5, when you put it over 1, it's now a fraction, but it's still -5. So whole numbers can be expressed as fractions by putting a 1 under them. So it's basically integers with most of the numbers in between. Now we do have something, you notice at the very bottom, irrational numbers. These are numbers that cannot be expressed as a fraction. Hard to believe that's true, but there you have it. Irrational numbers are never repeating, never ending decimals. Okay, so generally they are square roots of non-perfect squares. Square root of 4 is a rational number because the square root of 4 is 2. Square root of 16 is 4. But the square root of 2, the square root of 15 do not have actual whole numbers, therefore they are actually irrational. Okay. And certain numbers like pi and other things you haven't learned yet, but that's how it goes. So here is a nice visual. In the real number system, everything is concentric circles that get inside each other, but irrational numbers. Irrational numbers are the only thing that are kind of outside, don't really fit anywhere. So start with natural numbers. Move to whole numbers by adding 0, integers by adding the negatives, rational by adding all the fractions in between. Irrational, they're a little group all on their own. All right. Okay. Okay. Now we're going to list things. All right. List the numbers in the sets that they are in. So, this one right here. Which ones are natural numbers? Well, they're not the negatives. They're not the 0. They're not irrational. Looks to me like you don't have any rational numbers. It's supposed to be 0 with a line through it. Okay. Integers, non-decimal. So I'm going to have 0 and -7. Sorry, whole numbers had just the 0. Rational numbers, 0, -7. So it's this previous list. Now we add in rational numbers. Okay. 0.6 repeating. Remember, we said never repeating. So these are actually can be represented as a fraction. That happens to be 2/3. So this would be -2/3. Okay, so that's rational. Square root of 49, that's 7. So actually that goes back over here into integers because it's 7. And it's also in my natural numbers. So the natural numbers is not empty. Sorry, I missed the square root of 49. I just saw the square root. Okay, so this is going to be, whoa, sorry. Boy, I hit the wrong button down below here, and come on, eraser. There we go. We're going to get rid of that. All right, now we're back. Square root 49, which is 7. So that means whole numbers also has that. There we go. All right, now, irrational numbers are going to be the square roots that are not perfect. So 50, root 50 would be an irrational number. Real numbers, well, everything in there is a real number. Yeah, so everything's a real number, so all of it. So we have -7, -0.6 bar. We have 0, root 49, and root 50. Okay, let's look at the second list. Okay, in natural numbers, I have 3. But notice I've got square root of 81, which is 9. So that one would be. Whole numbers, we're going to add in the 0. 0, 3, square root 81, which is 9. Integers, now we can add in the negatives. -2, 3, 0. Oh, sorry. My mistake. That -2 is -2.3. So it is not an integer because it's got that decimal portion to it. Okay, so we still have 0, 3, and square root of 81. Rational numbers. Now we can gain the 2.3. So -2.3, 0, 3, and root 81. Irrational, square root of 8, because it is not a perfect square. Real numbers, all of the above. All right. Graphing rational numbers on a number line. Graphing is done by placing a dot on the number line in the correct location. So, if I have a number line, let's see, what's the furthest negative I go? -4.6. So we're going to do a -5. The highest positive is 4. So we'll just go ahead and go to 5. Put a 0 in the middle. 1, 2, 3, 4. Okay, those were not good. Fractional numbers. Okay, let's try again. 5. I need 4 tick marks, not 3. There we go. There we are. Okay, so red for -3. So we just plot -3. Green for 4. 4. 0. We're going to do blue for 0. 7 halves. Well, 6 halves is 3, so that's 3.5. So we're going to do black for 3.5. So we go 1, 2, 3, and about halfway to the next one. So that's 3.5. And -4.6. Let's try the orange. -4.6. It's just over half. And somewhere along the line, lost my dot. There we go. Yay. Okay. So those are that's how we graph these. Okay, now we're expressing rational numbers as decimals. Okay, so first we're going to deal with terminating decimals, decimals that end. Okay, so it's 8, see, I'm sorry, I keep twisting me out of this frame. Okay, so we have 8 into 3. Well, it's not going to go into 3, so we immediately have to give it a 0.0. All right, now 8 into 30, I get 3, which is 24. Okay, 3 times 8 is 24. Now, let's subtract, and I get 6. Now, 6 times, I bring down a 0, I'm looking at 60. 64 is 8 times 8, so it's not 8, it's 7. So that's 56. I have 4, I bring down another 0. 8 into 40 is 5, and we're done. The answer is going to be 0.375. Okay, now 3 into 5. Sorry, 5 into 3. Again, it's not going to work, so I have to give it a decimal. All right, so 5 goes into 36 times, but that gives me 30. So that means I'm done right away. Oh, I didn't finish this for you. 5 times 80 is 40. I just saw the end and just stopped. Okay, apologize for that. Now, repeating decimals. So these are going to be, the number's going to repeat itself. Okay, so now I have 3 into 2. Well, it's going to need to be a 20, so I have a 0 point. 3 goes into 26 times. That's 18. Well, notice I'm left with 2 again, so 20, so another 6. Again, 2, another 6. So this is just going to keep on going forever. So we can just go back up here and put a bar over the 6. So our answer would be 0.6 with a bar. Okay, this one was 0.6. No bar. All right, 7 over 11. So I have 11. Sorry, let me erase that. 11 and 7. Well, it's going to have to be a 70. So 11 goes in 6 times, 66, and that gives me a 4. Now, 11 goes into 40, 33. So that's 3. And that leaves me a 7. Oh, look, I'm back to the 7 I started with. So this is where I'm going to have a decimal, because now I've got 70 again. All right, so I end up with 0.63 bar over the 6.3. There we go. All righty, now we move on to the next one. Ordering the real numbers. Numbers on the number line increase from left to right. To indicate which are larger and which is smaller, we use an inequality symbol. They are less than for less than and greater than. Note, the larger end always on the larger number. Many of you remember from elementary school or whatever, the alligator. Please feel free to use the alligator here. He's always eating the bigger piece because he's very greedy. So, greater than. -6 is less than 25. 5 is less than 16. 2.3 is actually greater than a -1.2. -5 is less than -2. This makes it hard to remember this. All right, less than, I'm more negative, which means I'm less than the -2. I know it's can be confusing. Now this one gets a little difficult. How do I know which one is actually smaller? Well, I'm going to convert this into common denominator. Then it's going to be obvious. I just base it on the numerator. So 3 times 3, this is going to be 9 over 15. And 2 times 5, 10 over, 15. I hate it when I do that. Okay, there we go. All right, now which one's larger? The 10. So 3/5 is less than 2/3. Again, on the next one, we're going to do a common denominator. 7 times 3 is 21. 3 times 2 is 6 over the 21. Now which one's larger? The 7. Makes it easier. Just convert them to a common denominator, and then you can see which one's greater and which one's less. All right. Okay, so now we have, we're using greater than or less than equal to. Okay, so this is less than or equal to, and this one is greater than or equal to. Why would you want to include the equal? Well, it is possible that in two different forms they are equal. Like if you were using a decimal and a fraction or something like that, it's possible they're equal to. So we need to include that possibility. All right, use the greater than or equal to symbol. All right, so remember these are negatives. So -6 is actually smaller than -2. Negative flips things around. So, all right, 2/3 and 4/6, common denominator. So I'm going to multiply the first one by 2 over 2. That's going to give me a 6 denominator. So what I really have is this is 4/6. These are obviously equal to. So I can do either one I want. I could do less than or greater than as long as I put the equal to, because these are equal. All right, -4 over 2. That's actually -2 because 2 times 2 is 4. All right, so these are actually, again, equal to. So just for grins, I'm going to use the opposite. As long as I have the equal to, I'm good. All right, absolute value. Absolute value is the distance a number is from 0. It is always positive. What you need to visualize, if I have the point -2, okay, how far is that from 0? It's 1, 2. Distance is always positive. It's non-directional. All right, so 2, 2. They're both 2 away, right? 1, 2. All right, 0, 3, 25, 6. Now, since the negative is outside the absolute value symbol, this is actually -12. The absolute value on number 8, the absolute value turns that -12 into 12. So now it's -12, absolute value of 12. So that just gives me -12. Okay, absolute value, greater than, less than, greater than or equal to, less than or equal to, fractions. You learned a lot today. All right, so go work on your homework.